So you've been looking at adopting containers, also known as Docker containers. You understand the benefits of running your workload in lightweight containers, and you also want to run them in the cloud for scalability. In order to do so, you do your research and you find many success stories of this thing called Kubernetes. And to be honest, this is where things get complicated. But why? With containers and Kubernetes, there is a lot for technical teams to learn. We have to learn about Docker, containers, images, volumes, networking, pods, services, deployments, config maps, secrets, stateful sets, ingresses, persistent volumes, claims, and it never ends. So much to learn. And when you scale a team, things become challenging. You have to scale their knowledge, manage their access, things like single sign-on and two-factor authentication. Now let's face it, in Kubernetes there is a lot of things for technical teams to learn, and I've covered many of them in my videos, such as pods, deployments, secrets, config maps, daemon sets, ingresses, volumes, claims, all the way through to monitoring and service meshes. In all my videos I've placed a lot of emphasis on the technical side. All of this knowledge that has to not only go into one person's head, but multiple teams, distributed teams, some in an office, some even remote, all around the world. All this knowledge has to keep circulating as people leave and join the company. How do we take the burden off of these teams so that they can become more productive? How do we give all the teams access to many environments through a central platform where they can access multiple Kubernetes clusters, possibly on multiple cloud providers at their own scale, instead of insecurely sharing Cubeconfig files all over the place and having to learn a lot of command line? There has been a lack of focus in the space until now. Portainer is the central place to manage Kubernetes clusters at your own scale. Provide access via a central authentication point using your existing authentication provider and your existing roles to allow teams to take certain actions on multiple clusters or on multiple cloud providers. Today we're going to be taking another look at Portainer to see how it solves the business problem of managing multiple clusters at your own scale. Whether you're a new starter starting with one Kubernetes cluster, or you find yourself in a situation where you have multiple Kubernetes clusters, when you have multiple teams, multiple clusters, and you just want to make it easy for developers to get access through your existing authentication provider so that you can lessen the burden on your ops, DevOps, or platform teams so they can focus on what's more important. All of this using a central user interface. So how does Portainer solve this challenge? Well, leave a like, comment down below, subscribe, and let's take a look. Now the cool thing about Portainer is that it's not invasive. It simply sits as a UI layer on top of all your clusters and gives you the power to manage everything at your fingertips. Portainer runs as a lightweight Docker container, so it can pretty much run anywhere. This makes it extremely portable, so you can run Portainer anywhere. You can run it in a VM in the cloud or in a Kubernetes cluster. Then you can access Portainer and create a basic admin user. We firstly create a simple basic user that helps us set everything up. Once we log in as our admin user, we hit the home page where we can manage all our environments. Now, to manage a Kubernetes environment, Portainer makes it really easy by allowing us to install a Portainer agent in the environment to connect it to Portainer. We head over to the environments page and we click on add environment. Once we go through the add environment process, Portainer gives us a simple command that we have to run against our cluster to add it to Portainer. Once you have the command, Portainer makes it really simple to integrate with your cluster. If I have multiple Kubernetes clusters, I just go ahead and select my cluster and I go ahead and paste the command. This makes it easy for your engineering team to integrate Portainer with all your Kubernetes environments. Once we've added our environments, we're all set and good to go. The latest version of Portainer also allows us to create an environment, so we can provision a Kubernetes cluster on a cloud provider. It currently supports Civo, Linode, and DigitalOcean, which is a pretty exciting feature. Now we have a central view of all of our environments in a single place. Now we want to go ahead and provide access to all these clusters. Let's say you have a bunch of users from different teams. In an ideal world, you don't want to go ahead and add every single user individually to Portainer and manage all these user accounts. You most likely already have an existing user base. Something like GitHub accounts, Microsoft Active Directory accounts, Google accounts, the same account that users use to sign into their email. This security, password management, single sign-on, and all these features are something that's already managed by your IT department, or it's already managed by some other system, and we don't want to interfere with that. What we want is single sign-on within Portainer using our existing authentication, and this makes things super simple. All we need to do is add our teams in Portainer and then map those teams to existing groups that exist within the company. If we go to Microsoft Azure and we sign into my existing Azure Active Directory and I go ahead and type in my password, you can see that I have my existing two-factor authentication. I go ahead and sign in, and ideally I'd like to use this account to sign into Portainer. And in the Azure portal, I have an Azure Active Directory. If I go over to users, you can see I have all these users in my company, and this is where I enforce things like strong passwords, two-factor authentication, and more. And if I go back, I also have user groups. You can see here I have a dev team, I have a DevOps team, I have a QA team, and other teams within the company. So generally, businesses have operational teams that look after Active Directory and look after the user management. What we want to do is map these user groups to our Portainer teams. So Portainer makes it really easy to create teams. We head over to the user page to teams, and we can simply provide a name of the team and go ahead and create it. You can see here I've created a dev team, a DevOps team, and a QA team. And then what we want to do is map these teams to Azure Active Directory groups. And I've done so under settings, under authentication. I've enabled automatic team membership, and I've gone ahead and mapped the IDs of the groups in Active Directory to the teams in Portainer. This makes things really simple. What this means is that we never have to manage users in Portainer. When a user signs in, based on the group that they're in, Portainer will automatically provision a user within Portainer and assign them to the team they belong to. The same thing goes for when they want to switch teams or when they leave the company. They will automatically lose their access. With our teams now in Portainer, we can now fully manage access to our platform. Portainer comes with built-in roles, which we can assign to our teams for each Kubernetes environment. So we have environment administrators, so they have full access to a given environment, but they cannot make any infrastructure changes and they cannot make changes to Portainer. Then we have an operator which has operational control over the resources deployed in an environment. So you can see here operators have access to update, redeploy, stop and start containers. They can check logs and they can access consoles into containers, but they cannot create or delete any resources. So they have operational control. Then we have a help desk user which has read-only access to the resources deployed in a given environment, but can't make any changes to any resources. So they can't access the container console or make any changes to container volumes. Then we have a standard user which has complete control over the resources that user deploys. If the user is part of a team, it has control over the resources that the team can deploy. And then you have a read-only user which has read-only access to the resources they're entitled to see. So pretty granular control to make your teams productive. So for Portainer Business, we have the Manage Access buttons on our environments. So we can go to the development environment, we can say Manage Access, and here you can see we can go ahead and select a user or a team. So we can say the dev team, we can give them operator access, go ahead and create that, and then we can also go ahead and select the QA team and give them operator access to the environment as well. Then we can head over to the production environment, go ahead and say manage access, and we can give the dev team as well as the QA team read-only access to the production environment. We can also group environments together under environment groups. So we can create groups. If you're running multiple clusters for production, you can manage access at a group level. So I have a production group which holds 2 clusters clusters currently, US East and US West. I go ahead and say manage access. I can give my dev team as well as my QA team read-only access to the production group. Similarly, I can also click on manage access under production, and I can go ahead and select my DevOps team and make them environment administrators. Now, to showcase how the access flows, if I go to my Active Directory and I go to users, you can see I have this user called Alex. If I go into his account and go to groups, you can see that he is part of the dev team group. So this means we don't need to create an account for Alex within Portainer. Everything would be automatically synchronized. So what does it look like from a developer perspective when Alex logs into Portainer for the first time? So when Alex rocks up at Portainer for the first time, you can see we can hit the login with Microsoft button. If I go ahead and click that, that'll take us to our Active Directory to log in. I can then say use another account. Alex will type in his details. He can log in and do things like two-factor authentication. You can also see my Active Directory is enforcing extra permission on his account, which I need to go ahead and set up. So for company policy, we have something like two-factor authentication that Alex needs to complete. This means all the additional layers of security is taken care of by Microsoft Active Directory. So Alex can go ahead and sign in. And once he's signed in, we can see he hits the homepage of Portainer and he can immediately see the development and the production environments. Now, Alex is an operator of the development environment, meaning he can manage existing deployments but not create new resources within the cluster. In production, if we click in, he should be a read-only user. This means Alex has read-only view, so you can go ahead and look at the dashboard and kind of browse the cluster. So you can look at like namespaces, you can look at the applications that's deployed in there, you can see their states, and you can also look at config maps. So what if we decide to change Alex's role? Let's say Alex has moved from a developer role and moved into a DevOps team. This is super simple as all the changes are done and managed in Active Directory. If we head over to the user we want to manage, we go to Alex's account, we go to groups, we say add membership, and I find the DevOps team. Go ahead and select that, and then what I'm going to do is I'm also going to remove him from the dev team. So go ahead and do that, and after a few seconds, if I hit refresh, we can see Alex is now part of the DevOps team and no longer part of the developers team. So now let's say Alex arrives at his desk, he goes and logs in with his Microsoft account. We select Alex, provides his password, and now Alex is part of the DevOps team. We can see the change has taken effect because the DevOps team has production access and I did not provide development access in this demo. So now Alex has the capability to go to a production environment, and now he has greater visibility on the environment, and he can also get a kubectl shell into the environment. Since he's an environment administrator, he can even run a kubectl command. He can create a pod. We do kubectl get pods, we can see the pod is up and running. So this shows you how easy it is to manage teams and users within Portainer. Now, so far we've seen how Portainer simplifies the access via the UI. But what about the command line? What about users that like to run command line tools and are used to those tools like kubectl and Helm? Now with Portainer, nothing here really changes. Developers can continue to use their favorite tools. The key difference is that Portainer makes it really easy to provide access to the cluster via a Cubeconfig file. Without Portainer, people can insecurely share and send Cubeconfig files to each other. Also, many Cubeconfig files used by people do not have an expiry set, and this is super risky because it leaves your cluster open to unauthorized access. Ideally, you want Cubeconfig files that automatically expire. If I jump to my admin user and I go to settings, Portainer makes it really easy to manage Cubeconfig expiry. Under the Kubernetes section, there's a Cubeconfig expiry, and we can set that to a day, 7 days, 30 days, or 1 year. So it's important to set an expiry on your Cubeconfig. If I jump back to my Alex user, when Alex logs in, Portainer makes it really simple to get a Cubeconfig file. Right on the home page, if we go and press the Cubeconfig button, you can see that we're presented with a dialog where we can select the environments we want to access. It also tells us that the Cubeconfig file will expire in 1 day. So this adds an extra layer of security on top of our cluster access. So as Alex, I can go ahead and download a Cubeconfig file. I can then go ahead and take a look at that file. I can copy its path and I can set a Cubeconfig environment variable. So I can go ahead and set up my kubectl to use that file. I do kubectl config get contexts, and we can see we now have 2 contexts that we can access. We have our production cluster in East US and we have our production cluster in West US. Currently I'm accessing my East US cluster. I can do kubectl get pods and we can see I can access my cluster successfully. So now that you've seen what Portainer Business can do in terms of simplifying multi-cluster access and authentication, the question is, what does this Oauth integration look like? And how hard is it to get this set up with your existing authentication provider? So Microsoft offers a free developer sandbox for Office 365. If you head over to developer.microsoft.com, you can join the Microsoft 365 developer program. And this gives you access to a free Azure Active Directory tenant. You simply join the developer program by clicking the link and following the prompts, and then going through this step, it tells you how to set up an Azure Active Directory. And this will eventually lead you to the Azure portal where you can go ahead and experiment and play with an Active Directory. The Active Directory sandbox provides you with 40 fictitious users that you can use for testing. And this is great if you want to go ahead and try out Portainer Business with the Oauth integration. If you want to test sandbox without interfering with your company Active Directory, so you can play around with all the features. Now, integrating the Active Directory with Portainer is very simple. The first thing you have to do is go to your Active Directory and go to app registration. And then you can see I have a app registration called Oauth. So this is very simple to set up. You can click the new registration button, you give your application a name, and then you specify a redirect URI. The platform is going to be web, and this URL is the URL that the browser can reach Portainer on when it redirects. So once you hit Portainer and you follow the prompts to sign into Active Directory, Active Directory will redirect you back to Portainer. So in this demo, I'm just putting the local IP address of my Portainer instance that I'm running locally. I then go ahead and register. Once the application is registered, you want to go ahead and record a few things. You want to record the tenant ID for your Active Directory tenant and the object ID of this app registration that you've just created. Then you're going to want to go ahead and go to certificates and secrets, and you're going to want to create a new client secret. You go ahead and give the secret a name and set an expiry for that secret. You then click the add button, and what you have to do is record the password value because you'll only be able to see this once. The next step is you want to go into authentication for that app registration and make sure under implicit, grant, and hybrid workflows you have both of the access tokens and ID tokens ticked. And then you also want to go ahead and go to the token configuration and then add a groups claim for the token type ID, access, and SAML. What this means is the token that Azure AD will use for that user when they authenticate will have the group information within it. This will allow Portainer to read the groups. Then I'm also going to set the API permissions for that app registrations. I have OpenID and profile as well as user read. So this allows this app registration to sign in users and view a user's basic profile. So once you've gone ahead and configured your app registration, you want to grab the tenant ID, the application object ID, as well as the application secret. And then we're going to head back to Portainer as our admin user. We're going to go ahead and go to settings, authentication, and under authentication, we're going to select Oauth, and we want to enable single sign-on. You can also choose to hide the internal authentication prompt for your admin user once you have this integration set up. I usually like to keep this off in the beginning, which helps me use the admin user to set everything up. I want to go ahead and tick automatic user provisioning. I want to automate team membership as well. You can see I'm setting the claim name. That's the claim name that we specified in Active Directory called groups. This will allow Portainer to read the group information from the sign-on token. And then we can add team mappings. So under our Active Directory, we have all our groups. And under the group section, you can see all the group names followed by the object IDs. These are the IDs that identify the groups. So in Portainer, we want to add team mappings and we want to paste the group IDs in here and map them to teams that we've created within Portainer. So you can see here I've managed to map 3 IDs to the dev team, the DevOps team, and the QA team. So then what we want to do is fill out the Oauth configuration. So I've done that here, and all of these values I've documented in my GitHub repo. The same GitHub repo we've used for the previous Portainer introduction video. To briefly run through this, we give the client ID, that is the ID of the app registration, the secret of the app registration as well. Then I have a couple of URLs. So they're all login Microsoft URLs. All of them have my tenant ID as part of the URL. The first one is the authorization URL. That is the URL that Portainer will redirect you to sign into Microsoft. The following URL is what Portainer will use to get the token, and the resource URL is what Portainer will use to read user information. And then the final one is the URL to sign you out. That'll end the user session. Then you also want to give a redirect URL. This is what the browser will redirect to. So see that this is a local host, so it works on my local machine because the browser will just redirect me to localhost. If you're using a custom URL for Portainer, you want to put that here. And then the user identifier and the scopes. The user identifier is a field that Portainer will use to identify the user, and the scopes is what Portainer will use to retrieve information about the user. And that's as simple as that. So now you have Portainer and you've secured access to your platforms. But what happens next? How do they deploy containers, manage pods, and do things like GitOps? In my introduction to Portainer, we cover all of these features. Be sure to check out the link down below so you can follow along. And hopefully this video helped you understand multi-cluster management with Portainer. Let me know down in the comments below, how do you manage multiple Kubernetes clusters and multiple cloud providers? And remember to like, subscribe, and hit the bell. And if you want to support the channel even further, be sure to check the Patreon link down below or click the join button to become a YouTube member. And as always, thanks for watching, and until next time, peace.